All right, starting a little early tonight, but that is okay. Was able to actually get some NTP config done earlier today. Probably won't go through that, but I've been focusing on some of the systems management and IP services just to get more practice with those. They tend to have a lot of features and everything to enable and configure. So that's kind of just what I'm focusing on this week. I think what I'll work on tonight is some more infrastructure services stuff, and I'll probably play around with the first top redundancy protocols, so HSRP, VRP, GLVP, and maybe gets to some of the IPv6 stuff. We'll see. Didn't actually schedule any rack time with INE tonight. I'm going to be using Viral. So we'll see how that goes. It's been working fairly well for me. And I think without further ado, let me go ahead and get my screen shared here. And I switched it up from last night. As I was looking back at it, it looked a little hard to see everything. So I moved it to a second monitor that has a lower resolution, but should be easier to read and not make it so much black on the screen this time. All right, so let's get to it. All right, so we're going to do HSRP. I'm going to do it between router 4 and router 6 and set up a new gateway. So let's get that going. And we're going to do it on the 146, VLAN 146. All right, so we go into that interface and we'll do standby 1. So let's just talk through some of those features, right, or what the options are right there. So standby is for HSRP, Cisco proprietary. Group number, we can do 0 through 255. I try and match up to the VLAN number. So we'll do that. And then, we'll talk through some of this as we go through it. So let's do standby 146, just because that's the interface we're on. The IP that we're going to share between the two devices. And that's what we need there. So let's just get this basic set up. Again, this is practice, not speed right now. 146, and those sessions would have to match on both sides. All right. Now we should be able to do a show standby. Right now it's listening. Do debug HSRP. Do debug HSR IP. Oop, I know that's going to be a lot. HSRP. Debug standby. There we go. I don't know why I wasn't thinking that. We'll just do everything. Let's watch it all. So I could see while we were waiting, do on all, because that's going to be a lot. All right, so let's take a look at this output here. All right, so router 6 is the standby right now. We can see that it's using the virtual one state change. That just means it was coming up. We have the virtual MAC. So what we can see here, we know it's HSRP based off of this MAC address right here. So the AC and then 92 in hex should equal out to be 146. Let me pull up a calculator. Let me change that to programmer. And let's see. 96. And we should be able to put that, let's see, I'm not good with this calculator. Nope. I'm always better with the Windows calculator, but I don't have a Windows machine. Oh, that's embarrassing. Let me get that out of there. And let's see. All right, so we got it up. We want to make sure that router 6 is actually the primary, unless it loses connection to 146. All right. So what we can see, default priority is 100. HSRP, the higher priority, the better. We can see router 4 is actually the active right now. Standby router is router 6. So if we wanted to actually influence router 6 to be the primary, we need to do standby 146, priority, and we'll just do 150. I like working with that number. And let's make it actually happen. So preemption was, as we could see up here, is disabled by default. So we'll just enable preempt there. That should be able to take it over. And we can see that it did. We can see that it went from standby to active. I'm sure if we went over to router 4, we could actually see the same, that it went from active to standby. And that is what we do see. It also wants us, let's see, it wants us to change the hello and den intervals to 1 and 3 respectively to make this happen faster. Let's do it on router 4 since we're here. Let's see, timers, that's what I need first. So we need the hello, which is going to be 1, and the hold, which will be 3. And I could copy and paste it, but we're going to practice typing. Timers 1 and 3. Show standby. And we should see that updated here, which we do. And we want to be able to authenticate with MD5. So standby 146. I'm pretty sure it's authentication. It is. MD5. And we are just going to do a key string. Key string of Cisco. And we can see it lost bad authentication, so it's nice that it just tells us why is it broke. We can see router 4 went back to being active. I also think oops. So they are both in the active state right now. So if this was a production network, might not be fun. Get some unpredictable traffic patterns. Standby 146. Authentication, Cisco. And we should be good to go. So we'll just give that a minute to come back. Because router 4 should be the standby based off everything we did here. And let's see. Let's just add preemption there. Did I type something wrong? Let's check that config out. That looks good there. Still says bad authentication. Oh, I know why. I can see it. We did not make it MD5. MD5 key string Cisco. There we go. All right, that is one of my classic moves of skipping something like that. All right. So let's see what else is going on. All right.
You didn't have a temp?
Yeah, let me just pause that real quick. All right, and we're back. All right, so we got everything done there. What else can we actually configure here? So let's do a standby 146 question mark and see if we missed anything. We did IP, we could do IPv6. We could change the MAC address if we wanted. We can add name. Doesn't see name change, so I think that would just change this right here, which is just the default name. The tasks don't actually tell us to change the name, so I don't think we need to. And we did preemption, that's off by default. Priority 100 by default, we higher the better. Timers, and then tracking. I think that will probably be something that we could try. So if we actually wanted to track, and we'll just track 46. And we'll decrement. And let's see, we're going to decrement it by 70, right? And then if we went to track 146, we can do interface gig 146 line protocol. So that way, if it went that way, if 146 went down, it would be tracked with HSRP and decrement down. So that would be a way that we could use track. I don't think there's much more to do there. It is a way for us to get a active-passive load balancing technique there. So let's see, is there anything that I want to take notes on? I don't think so, but let me, 146. Let's copy this out. Let's do a show standby as well, just so we can get everything. And let's copy that into the notes over here on the other screen. Let's do the same over here. Cool. Got that out. And I think HSRP would be too difficult. It's all right. Let's go to the next thing. And the next thing is VRRP, so the industry standard version of HSRP. Couple differences there, but we'll talk about it as we go through. I am not going to remove the HSRP config just because I don't think it's necessary. But that's okay. We can leave it there because they can both coexist. I think we just can't use the same number. So let's see, the task wants it on router 4 and router 6, same interface, but use a different gateway address. And we want to ensure that router 4 is the active gateway and use a different, all right, so VRP, we'll just give it number 1. We're going to say IP is 155.146.253. We're going to say, oh, this is on router 6, so that's okay. And you know what, let's step through the basics again. Let's just keep it simple. VRP1 IP 155.1.146.253. Okay, so router 4 is the backup. We have this. You can see that the MAC address right there. Preemption is enabled by default, which is different than HSRP. Priority 100, masters router 6 right now, and got some timers there. All right, so we want router 4 to be the active. So let's do VRP1 priority, and we'll do that 150. We want to authenticate with clear text. So actually we could just say Cisco bad auth, which is good that it just tells us that. It should be good there. All right. I don't think there's much more to do there. Oh, right, we need to do our timer. So VRP1, let's see, timers, and we want to do a hello of 3. So let's actually just configure it. Let's do 3. Okay, not much to do there. VRP1, timers, advertise 3. So VRP, we are the master. We can see that the advertisement's every 3 seconds. And then it goes down if it misses after 9 point something seconds. All right. And again, I don't think there's too much there, but let me do show run int gig 01.146. And let's get the show output, and we'll clean this up later. Just because it has all that HSRP config in there.
Hey, Chris.
What?
Ethan needs hugs and kisses.
Okay. All right. I will be right back one more time. All right, I'm back. All right, let's see, where did I leave off? All right, so we just did VRP. Let's do some, let's see, what's next? GLBP. GLBP. All right, so there is actually no lab for this, but I think we'll just continue with the same thing that we've been doing, which is using router 4 and 6. So let's get that going. So GLBP 2. Okay, same thing here. Basically the same config. Major difference though is that we have both routers could actually be the active gate, or both routers would respond. So let's just do 250. And let's do the same GLBP 2 IP .250 GLBP. Okay. So we can see once this actually gets going. All right. So we're still in the listen state, but it did learn about router 4. You know, let's do the show output one more time just so we can get everything out. We can see everything's active. All right. So we got the virtual IP that we just configured. Hello and hold time. When it will be sent next. Preemption is disabled, so we'll need to enable that. Active is router 4 with a default priority. We have no weighting changed, so and the load balancing method is round robin. So router 4 and router 6 would keep go back and forth between who is what. The forwarder 1, which is router 4, is still in listen. Let's see, this state is active. Let me highlight so you can see what I'm reading. So forwarder 1 is still in listen. We can see it's got this MAC address, which we know is GLBP based off of this. We can see that the owner ID is that. I don't know what the owner ID is. I'll have to look into that. Preemption is enabled, minimum delay 30. All right, let's do one more show output of that, just see if anything is changed. Don't think so. All right. Okay, so we can see that there's 2 group members. Do show int 146. Is that the MAC address? That is the MAC address. All right, so that's what the owner ID is. That is the MAC address of the other, but they will share that. Do show GLBP. All right, let's look at some more we got there. Let's see, what load balancings do we got? So host dependent. So it must be based off of the MAC address weighted, so we can change the weight and get maybe like a 3-to-1 or something ratio there. I'm gonna play with the weighting there. Forwarder, let's look at the forwarder config. Preempt. All right, so that just is preemption. You know, we can just add preempt. We're not gonna delay. GLBP to preempt. Let's change the timers to be faster. And let's make router 4 the prime. You know what? Let's make router 6 the primary. All right. I don't think there's much else to do. I mean, I could probably play with the weighting and whatnot, but not sure what else we would get from that. Show run int. You can see, just like I did last night, I don't necessarily remove other config as long as it's not conflicting. And we copy that out, put it into our notes. And let's see, the other thing we could probably do is router redundancy and object tracking. All right. So let's come back to our HSRP config here. And let me just see what's going on. All right. Cool. All right, let's get this going. All right, so we want to be able to track. So router 6 should be the active gateway for HSRP as long as it can reach VLAN 7 through telnet, but not be and give up the role if it can't either lose its telnet or ping to that VLAN. When VLAN 7 goes down, router 4 should take over. So do show standby. Where did we add the tracking? Track. We did not do it here. I think we did it on R4, right? Oh, track. Yep. All right. So that's not going to conflict with this. So we could do the redundancy tracking in two ways. We could do an IP SLA and ping, and then call that SLA from a track, and then put that in there. And I think that's the way I'm going to do it. IPSLA, let's call it 67 because it's router 6 to 7. And let's see, what are our options here? We are going to, we could do a TCP connect, which might be interesting, but let's make it simple because it said lose ping as well. And let's do 155 because we need to get to router 7's VLAN. And let's see, it does not say where we need to source it from, so as long as we can reach it, and then we can do a track 67, and then that would be from list, nope. It's not application, but I'm curious what that is. Track SLA 1. Nope, we called it 67. And we want the reachability. Do show IP SLA 60. Let's see, show IP SLA. We want statistics. Right, because we never started it. IP SLA schedule 67, start time. Now, lifetime, forever. Because why would I make it more difficult than I have to? IP SLA stat. I don't know why I can never type statistics. All right, cool. So we are getting an OK return code from that on a ID of 67. And we could do a show track. And we can see that it is looking, the reachability is up. Last changes, we are good there. So let's go back into the interface. Standby 146, track. We are tracking object 67, and we are going to decrement by 70 because our, let's see, actually we could just decrement by 100. And we should be good. Yep, okay. So we are the reason I picked 100. We are currently at the prior 100 or 150. That is what we configured. We know that router 4 has 100 still because I'm pretty sure we never changed that. And if I could actually type correctly, that is right, still 100. So if we just decrement by 100, if we lose access to VLAN 7, we should be good. We can see that's working right there. So let's hop into router 7 and simulate the failure to see if this actually works. So let's see, .7 and shut down. So that was shut down. We can see admin down. Not sure why I didn't log to the console for that yet. We can see it's in a timeout right now. It's getting a failure. We can see the SLA just went down. We went from active to standby. Router 4 became active. Perfect. That is what we wanted. Let's do a no shut and bring that back up. Always important to bring that stuff back up. And good. All right. Let's check what I'm doing against the solution guide there. So I made it far more complicated than it had to be, but I think that is a good thing. So the solution guide is just showing to do a track and then decrement. Track 3, which is I feel like they skipped some of their config here. Oh, all right, so they used a different initial config. All right, so I'm just using a base connectivity one. So if we just look here, I am just doing, basically it's just running EIGRP everywhere. And that's how I'm getting my routes from all the different interfaces. They had one that, INE has one called Object Tracking Initial. I did not load that up because sometimes I don't think it's necessary to have all of these different initial configs. But let's take a look at that initial config real quick if I can find it. Let's see, if I knew the object tracking and we want router 6. Yeah, all right, so we can already see they have a track there, track. And they just put a delay of up and down, delay of up and down, so check that. IPSLA 1, which is probably somewhere down here. Yep, IPSLA 1. Do this, they just added some timeout and stuff, which is fine. They started it. Okay, so they did a TCP connect, which I could have done as well. It wanted it based off Telnet. So let's do that. Let's actually configure this up, because that would be fun to track. And I think, kind of wish that the guide actually had us configure this. All right, so we're going to do an IPSLA 66, I guess. And we are going to do a TCP connect to 155.1.77 on the port, which is telnet. Enable or disable control packets. I don't know what the default is for that. We're just going to do that. And we need to start it. Let's see if we can just cheat a little bit there so we don't have to type this whole thing. All right. .66 still hasn't run yet, so let's give it a minute. No connection. All right, so let's go back into we need to stop that right now. That way we can go back into it. All right, so let's add that in there. They had it in the initial config here. So let's see if that makes a big difference. Socket connect error. Can we tell that to this? Well, that might be our problem. That's better. Let's see if that SLA will recover. All right, got that back up. There we go, got a return cast. Good. Okay. Now we want to be able to track both. So let's do a track 66 IP 66 state. No, I want reachability. Although state would be okay too, because as long as it gives back an okay, that would be fine. But let's do a reachability. And then what we could do to track everything is we could track, we'll just call it track 146 or 36.7. Nope, too high. Right, because 1,000 is the highest. So let's do 667. And we could do a list Boolean because we want to do both, and we could do an and we can do, let's see, what are our options here? Not much. Object, we want 66 and 67. All right, so we have a Boolean, which is looking, or we have a new track that is looking at both IPSLA 66 and 67, which are tracking two different things. 66 is tracking the telnet capabilities to router 7's VLAN 7. And we also have IPSLA 67, which is pinging VLAN 7. So that should be good there. Let's see, what else? I think the only thing I would have to change is actually where the tracking is, but that's pretty self-explanatory there. So I should probably pull out all of this, not pull it out, but copy it all out. Like section, let's see, we want track and SLA, because those are all good. Those are all good ones right there. And we want to do the show IPSLA stat. Let's do a summary as well, just for fun, and a do show track. All right, let's copy all those out. I think those are really good show outputs just to remember and see how they work. And putting everything into OneNote like I was before, and we can see my crazy organization. So we got that going on here. We got the first hop redundancy protocols. I could probably throw some notes into there. Probably don't need to. And let's see if IPv6 stuff. So IPv6 I am very weak at, and that is probably a good thing to go and make sure I understand. Let's see, do we have a lab to work off of? I do not see a lab for it. You know what? I don't think I'm going to do any of my learning live here, but what we can do is add that as a to-do. All right, let's just add that to my to-do list. So IPv6, RS and RA redundancy. All right, added to the to-do list. And let's see, what's next in INE's eyes? Where are ICMP settings? Wants us to go to router 1. Let's just take a look at this one real quick. So configure VLAN 146 to stop sending ICMP messages about discards and ICMP messages to, so basically to stop sending a whole bunch of stuff. So no ICMP. No IC. All right, so we don't want anything about discards. So no IP unreachables. No IP, and we don't want anything about selecting a better next hop. So no IP redirect. And we don't want anything about ICMP messages reporting subnet masks. No IP. I think it's subnet or something. It's this. Yeah, mask reply. And we also want to rate limit ICMP on reachables to 2 seconds globally. IP ICMP, which we want to rate limit the unreachables to 2 seconds, because that is in milliseconds, and it doesn't ask us to log anything. All right. Yeah, let's check. All right. IP redirects are never sent, and mask replies are never sent. So that's verified there. All right, that was fairly easy. I don't actually know where that is in the notes of things, but never hurts to look at the wording of those and just kind of practice that config. All right, what's next? Let's do some DHCP. So that would be under, I think, where is DHCP? I was looking to see if there's a lab that already exists for this first. I could have sworn there was a lab for this. There is for DHCP snooping and stuff, but not for actually setting up a DHCP server. I could have sworn there was one. So the NAT stuff. Interesting. All right, we're gonna do it on router 8. And the reason we're gonna do it on router 8 is because we can make router 10 be a client. Better idea. We're gonna do it on router 5. And that way we can play with relay as well. That is a much better idea. All right. All right. Router 5. And let's see. All right. So we have interface 58 that we could play with. We can make it so it can't give out. So we're going to start with doing the excluded address first. And we'll just say 155.1.58.5. And let's get rid of 1.158.5. So we're only going to exclude one address, our address that can't get out. So we'll do it that way. And let's see. So we're only going to do one. And then we'll do an IP DHCP server. Nope, IP DHCP. And we're going to make a pool. And we're going to name it DHCP because, you know what, we're going to name it DHCP 58 because I am not creative. Okay, now in here, we got a bunch of stuff that we can do. And let's just start off with the simple stuff first, which would be, we are going to say the network is 155.1.58.0, and we'll just call it /24, because why make it harder? We're going to do the default router of us. You know, we don't think we need to do any of that. So we get the network. We could throw the domain name, but that's not going to be, we're not going to be able to really test that. Same with DNS. We did the default router. We're not going to do any accounting class. I don't know. Hardware address. That's if we wanted to do that. Blah, blah, blah. Relay, some that. Update. All right. I don't think we need to do much else in here. So we also need to service DHCP. That has gotten me so many times. All right. We're going to look at this interface connecting to router 5. If I can type. Let's see, 58 IP address DHCP. Cool. So we can see we released one address. We could do 1 through, I don't want to look at the binding. Great. Okay. So what we can see is we got router 8, because I'm pretty sure it picked up an IP because we saw EdgeIP come back up. And we can see that interface learned its address from DHCP. Cool. And what else? You know what? I'm thinking router 10 probably won't be able to be a client. I don't think it'll be able to be a client because we got to pass. Oh, no, we could. Yes, we could. All right. Sorry, I'm thinking ahead. All right, so we got the client identifier. And when the lease is going to expire, I didn't set up any of that, but at least that worked. We're going to make another pool, IP DHCP pool DHCP 108. Okay, network 155.1.108.0/24 mask. There's more than one net thing in there. And then we're going to say default router is 155.1.108.8. And what we are going to do is come to router 8. We're going to go to its interface here, IP, DHCP helper. Is it just IP helper address? 155.1.58.5. Okay. What we should see after we go to this interface and do IP DHCP, oops, IP address DHCP. We should see the adjacency go down. And then this should request, yep, there it goes. We can see I just got assigned an address from DHCP. So what the helper address does is it actually forwards the broadcast request of DHCP. And since routers don't actually forward broadcasts, we needed to use the helper address to relay that on to the server. And that's what we did on router 8 here. With the helper address, we told it the IP address of the DHCP server. That then sends the request back all the way to router 5, which is it doesn't really matter how many hops away it is in our case, but it is beyond the router itself. We then can see that IP DHCP binding. We can see that we handed out another address from here to router 10. And we also get our adjacency and everything back up with eager because they got an IP address. I don't know what else from a client side. It's just going to be IP DHCP. Pretty sure I could probably play with, there's a few other things in here. I don't know what else. I think this is going to be one of those where I can just kind of read through the configuration guide and see what else there is. But from a basic understanding, I think I've got it there. Man, am I surprised that the INE doesn't have something for DHCP. Other than snooping and ARP inspection. That is surprising. I could have sworn I could have sworn there was a workbook. Let's go check. No, and I got logged out anyways. All right. It might have been from my boot camp. That might have been where I saw that lab. Nope. It's not, but there are some good labs in here that I should probably revisit. That'll probably be some good things to revisit. Yeah, because there's some DMVPN, OSPF, good redistribute. There's redistribution. This is kind of coming back to me. Redistribution, BGP, MPLS, multicast, and IPv6. So basically the core stuff. All right, how do we get back? Maybe it was in V4. It was a V4 lab. Sure is. It was in a version 4. That's how long I've been doing this. All right. So let's see. Let's take a look. There's nothing that I really didn't configure other than, so let's go back to router 5. So the couple of things that I could have added is actually storing the DHCP binding database. I could have, I meant the IP DHCP database, and we could just send it to the flash DHCP database. There we go. But we did the default router. We could have done DNS. That was easy enough, and we could change the lease. That's fine. Let's look at what do they want us to do under DHCP client. All right, so the only thing we could have done extra here, IP, we couldn't have done a client ID and told it to be, okay, you need to use your 108 interface as your client identifier. But I don't think it lets you do a sub interface. And that might make sense just because there's no actual, well, it's a fake MAC address to that. But that could just be so that if we wanted to know what it was. DHCP relay, we just did it with the helper address. So we are good there. Host pools, create a host pool. Oh, that might be a good one to play around with. Let's make it so all right. So we have this here. I'm not sure which one is do show and again. I don't know if that's going to work. I don't know if that's going to work. But what we could do is inside here, or we could do a client ID. And it would be this whole thing, which I will throw into see, this is where that's not a MAC address. It's too many MAC addresses. I'm wondering if it's using all of them. You know what, I don't think this is going to work here. Just because we're not using a physical interface. But let's just paste that in there for fun. Right, all right, let's just make a new. And then we can say the host is going to be 108.10 and .10, and it's going to be a /24. And then if we did on router 10 a shut, so that should get rid of the lease there. Do clear IP DHCP binding star show IP DHCP binding. No, shut that. Let's bring that back up. Yeah, see, I don't think that was going to work. I don't think that was going to work. Probably could have debugged it, but that's okay. So let's just take a couple notes on that. So that would be based on the MAC address, the client side, IP, DHCP, pool, host, pool, and that would be client identifier. I'm pretty sure it's a MAC. I remember there was a trick that if if you didn't know the client identifier, you could just create the DHCP server as it is and then look at the binding table, which we can see here. And there's a way to, like, this used to not be that long. Pretty sure this is what's screwing it up, because I don't remember these being like that. I think this is because it's a virtual environment. That you could just build it, steal the client ID, put it in, and then put that into your config, and that's how you would get the that's how you could easily get the client identifier, because it's different than the MAC address. I think the only difference was that it's 01 and then the MAC address of the actual client there. On-demand client pool. This, let's see, what is on-demand client pool? Allows for using various methods for IPCP, so that would be with point-to-point. All right, so that's just if we're doing a point-to-point interface, or yeah, PPP encapsulated interface, and we wanted to get we would get the address from IPCP, but then import any of the information that we learned from that into a DHCP pool there. I mean, that would be a good thing to practice. Not something that I have set up right now, but let's see. Let's see. All right, trying to think, where can we set this up? We could probably set it up on R9 to R7 and do it there. This will be a impromptu PPP config, but that's okay. I'm pretty sure R9 is at the end. Yeah, all right, so we could do it between router 7 and router 9. And let's make this the client side. PPP. All right. Let's try to think. All right, let's get this, let's just start typing. All right, so we're going to remove the address on here. We are going to int dialer 79, encapsulation PPP, IP address 79.9, dialer pool, dialer group 79, and we wanted dialer pool 79. Don't think we need anything else there. And 79 dialer. So PPPoE client dialer pool 79. All right, client side should be good. Let's go back. Let's go to router 7. I'll just do the global for now. And we're going to do virtual template 79, virtual temp 79. Oh, I just realized I think I'm not sharing anything that I am typing. So let's get over there. All right. We're going to do IP address 159.179.7. I just realized that I wanted to do IPCP or IPCP. That's okay. Let's get this working first before. Cool. All right, we got that coming up. Cool. Okay, so we're going to learn the address via negotiated. We're going to go back under the virtual template, and we are going to do IPs. What is it? PPP, IPCP, address. Nope. IPCP, let's see, what are we looking for here? None of that. We are looking for something different. Let's see, what are we looking for here? We want to be able to talk to our neighbor with PPP. We want to give the address. Peer IP, address. Nope, peer. All right. We're going to do it from DHCP. All right. I think I went a little overboard with this, but Definitely went a little overboard with that. That's okay. All right. I think I went a little overboard with this to show IP. Yeah, I totally screwed this up. That's okay. And not even what I was planning on doing tonight. I think a lot of this has to do with PPP. I am going to have to look into this further. Let's see, what else do I want to go into tonight? What else do I want to get into? You know what? I think it might make sense to get back to I think it might make sense to do some routing stuff real quick. Not real quick, but let's do some BGP. I'm just looking through the list here of what did I actually need to practice. All right. Pretty good with communities. Pretty good with the best path selection. Let's do some BGP filtering. So we need, all right. Let's bring up viral here. Let's stop this because we don't need any of that anymore. Let's just let that stuff close out. And while that's closing out, oops. Let's look for BGP filtering with prefix lists. And we need the basic BGP routing. There we go. Let's start that up. We'll give that a minute. Let's just see what's going on in some of the chat rooms. I don't think anything else is going on. Yeah, that's taking a little bit of time. That's all right. All right, that is up. Let's get connected. Let's clean the window up. All right. So I'm just gonna leave these windows in chaos. I'm not gonna move any of these around. But we will let everything get back up. We can see that we are first gonna do everything on router 2. So configure a prefix list on router 2 so that it does not accept the prefix 222.22.2/24 from R10. This should be applied directly to the neighbor. And then we're going to configure router 7 so that it does not accept any prefixes with a subnet mask of /24 or greater from router 9. And we need to do that with a route map. All right, so let's stick with router 2 because this one seems pretty easy. We are filtering with a prefix list. This will be good practice for just anything prefix list. But before I do that, I am going to change the lighting in my office. It is bothering me right now. Hey Siri, set study.
Okay, it's set. Hugh says, okay.
Oh, that hurts the eyes even more. Let's change this up. I'm still trying to figure out what's a good lighting for studying. This is not though. This is bothering me quite a bit. That's too dark. Nobody will be able to see me. That was what we just had. Dimmed is too dark. That's pretty good. All right. Distractions aside. Okay. So we want to do an IP prefix list. A prefix list. And we're just going to call it filter from R10. Oops. And we are doing a, so it does not accept. So we are going to deny 222.22.2.0/24. And then we need a permit. 000. And then we need anything less than or equal to a 32. All right. So we're going to deny that, and we're going to permit basically anything else. Run 5 section. This is probably just normal BGPs. This sure is. So before we do that, let's see how we're actually learning. All right. So we're learning it from this neighbor. So we want to, under router BGP 200, we're going to do a prefix list in, so router BGP 200, neighbor, prefix list. All right, This must be R10. We're going to do it inbound. Do clear IP BGP. Do clear IP BGP. Star in. Okay. Probably should have checked the whole BGP table first. Here, show IP BGP. And we are still learning this stuff from that neighbor though, right? We got that. We got some things down here. I think we are good. All right. And then on router 7, let's just take a look at this real quick. All right, we don't want anything with a subnet mask of, all right, do not accept any prefixes with a subnet mask greater than /22. So we should see 1, 2, 3, 4. Well, 4 of these disappear. All right, so what is the IP prefix list? You know, we could probably just do a permit. And then anything less than or equal to /21, right? Yeah, less than or equal to /21. And then do show run type section BGPs. And we wanted it from router 9, router BGP 300. Oh, and we want it with a route map, right? Yeah, it should be applied through a route map. So route map. Permit match IP address prefix. Pretty big list filter from R9. If it matches that. Let's see, do we need to add a catch-all permit after this? I don't think so, because we are matching anything. Yeah, I don't think we need a permit. Let's see how this works. Router BGP 300. Neighbor, route map from R9. Inbound, do clear IP BGP stars in. Do show IP BGP. And that did not work. Why did that not work? Let's see, we are permitting anything. Do show route map. Matching that, we copied everything. Do clear IP BGP star in. Do show run type section BGP. because we only cared about from router 9. All right. Right. So we did lose. Okay. That's what was confusing there. We did lose some, right? Because we should have lost this one. Because we learned it from router 9. Now we get it from router 3. So let's just check out that prefix. We can see now we're learning it through R6. All right. I think we got that right. Let's check. Sure did. Do show IP BGP regex. And that would have been 54. From 54. That's okay. That's a /8. Okay. I think we're good. So let's check the solution. Anything less than, so they put less than or equal to 22, but this says anything greater than 22. Oh, I wonder if that makes, I wonder what that means. That's all right. All right, so we got that prefix list configured. We are filtering what we want. All right, let's do filtering with a standard access list. So it wants us to remove what we just did. So do that, do clear IPBGP star in. And where did we do the last one? I think we did on router 2, sure did. And get rid of that. So do clear IPBGP star in because we care about what the results are. All right. All right, so we should have that back. We should be learning that back in, and we do. All right, so we need to do basically the same thing, but with a standard access list, and let's get that going. All right, so IP access list, standard ACL from R10, deny 222.22.2.0, 1, 2, 3, 4, and then permit anything. Okay, let's router BGP 200, 192, 10, 1.254. Oops. And we want to apply this directly. So this would be an not activate. Filter list. Nope, that's an AS path. Oh, it's a good thing I am practicing this. It's amazing what you forget so quickly. It's amazing what you forget. We don't need that. We don't want to prefix it. What am I forgetting here? What am I forgetting? Distribute list. And then what did I name it? I already forgot. ACL from R10. Inbound, do show IP access. I guess my show IPBGP is gone. Nope, there it is. All right, distribute list. I gotta remember that. For access lists, it is a distribute list in a routing world. That's how you apply an access list in routing. I don't know why I forgot that. That's why we revisit things. Gotta keep them fresh. Gotta keep it fresh. All right. And we want to do the same thing on router 7. Ugh, I don't like these. I don't like these. So we want to, okay. So we already removed the route map there. So we want a standard access list that does not accept any prefixes with an even number in the first octet from router 9. Okay, let's first make sure everything looks right. Yep, so we're learning stuff from router 9 again. Okay. So we need IP access list standard ACL from R9. And we want to only permit prefixes with an even number in the first octet. All right, so if we wanted to permit an even number, that means we would need, well, first we want to permit. And then if we looked at it from a binary perspective, we want to permit anything with an even. So if we said a wildcard, so instead of being a 1 there, we want right? Because we are saying match, right? We are saying match. Let's bring up our cheat sheet here. Bring that up a little bit, make it bigger. Let's bold that, center it. Okay. So that was from last night. So anything even would not have a bit set here. So that would be a 0 versus a 1. And we would need a 1, and then doesn't matter for here. This would always be odd numbered, even numbered. So if we wanted to permit, so it's basically a reverse permit, right? Because you can't just put a 0. Can we put a 0 there? You know what, I think INE has a pretty good way of learning this. I'm going to have to go back to it to understand it better. So let's take a look. So it's a wild card because if it was, it would be a 1. We want the even. Let's give it a shot. And we need to apply it through a route map. All right, so we're going to apply it through a route map. Let's see. Oh, we just got one doing that, so let's just get rid of this. Put back in, match the address, ACL from and then VGP 300. Still getting that in. Maybe we're going to give BGP long enough. Yeah, I think I got it backwards. Think I put it in backwards. All right. So it does not accept any prefix with an even. All right, so I actually got the result with it backwards. You know, I want to, you know what, let's change this access list up. So let's get rid of that. Because I read it as we need to permit even. I'm wondering if we just do that. Do show IP access list. Okay. It's just the BGP being too slow. Now we're denying. Now we're denying the odd. Okay, but we wanted it the other way around. That's something I got to work on so that it does not accept it's easy to read over those keywords that change the whole entire thing. All right, and I think this will be my last one of the night. Okay. You know what? I think I will call it a night. At least for the live stream. I think there's a few things that I need to read up on and kind of practice that a little bit more. But I think this was good. So I was able to get through NTP today, which nobody saw in the live stream, but I was able to get to that earlier in the day. And then we did some first hop redundancy protocol. So we did some HSRP, VRP, JLVP. We also did the object tracking. We played around with different IPSLAs and the different tracking, also doing a Boolean list. I have the IPv6 redundancy stuff that I need to look into. We did the DHCP server and whatnot. I got to go write those notes up. And then we just did some BGP filtering just to kind of even out with some routing practice as well. So I think that's a good night for the live stream. I'll get back to some of this on my self-study on my own. Still trying to figure out the live stream thing, so I will hopefully improve over time. But I think for now, I will keep this up just to get the flow down, and I think on Saturday or Sunday, whatever day is going to be my full day labbing, I will do I think I'll do a foundations lab just to get back into things. I might do maybe a troubleshooting. A troubleshooting might be good to play with as well. But I think that will call it a night. So thanks anybody that joined, and I'll see you next time.